All right, this video is about cross-country planning using dead reckoning. So this is really geared toward the student pilot who's learning to do cross-country, do flight planning, rates, times, fuel, that kind of thing, using an E6B, using sort of an older method that you can argue, many will argue, has been replaced with ForeFlight. But we're going to use ForeFlight because that's the tool that most people are going to be using today. So we're going to use ForeFlight for a planning tool, but we're going to do this assuming that you're not going to have ForeFlight in the cockpit. We're just going to have the basic instruments in the airplane, specifically a heading indicator, and of course the ones you fly with. So we're going to use the manual E6B to calculate our stuff. We're going to use, as far as getting all the information, we're going to use ForeFlight. And ForeFlight's going to be a really helpful tool. So this is kind of this is like the old school paper version, except we're not going to use paper charts. We're going to use the charts that everybody has, most everybody has available to them, and the ones they're going to get used to using. So in reality, you're probably going to use ForeFlight for everything, but as an examiner may ask you, what about when it fails? Well, in the planning stage, it's no big deal if it fails. In flight, if it fails, you go back to this kind of plan that you've made. And maybe this may seem irrelevant to a lot of people, but the reality is doing these things this way teaches you more about what you're doing, what you're dealing with, and what to expect. If you know what to expect, then when you make a mistake on ForeFlight or whatever app you use, then it's garbage in, garbage out. You make a mistake, it gives you a bad result, but you may not catch it. If you know how this works, you're more likely to catch these type of things. And of course, it's just instructive. Not to mention the other thing, and that's that it may be required by your examiner. So let's learn how to do it. So today, what we're going to do is we're going to plan a flight from, I'm in New Mexico here. We're going to be planning a flight from Hobbs Industrial Air Park, which is NM83, November Mike 83, to Levelland, Texas, up to the north. That's KLLN. That's Lima Lima November. So what we're going to do, we're going to plan a straight line flight. So this is this is the kind of cross country that your examiner would have you do on a check ride. Plan out and start executing. They want to see, this is pretty common in my experience anyway, they want to see that you know how to plan it, and they want to watch you execute it in a way that is reasonable, makes sense, that shows you can actually do what you say you can do. So what we're going to do, we're going to start by, let's write some of these things down. So first leg, and I just have a sheet I made here. We're going to go from NM83. We're not going to go straight to Levelland, though. We're going to have several legs. Now, this is a straight line distance. This is one straight flight plan. But we want to have checkpoints along the way to sort of calibrate and check our planning. So essentially, we're starting in one place, and we're saying we're gonna look at all the winds. We're going to take our airplane performance numbers. We're going to look at the winds aloft where we're going to be flying, and we're going to then say, all right, considering all these conditions, we're going to need to be pointed in whatever direction. Maybe we're going to need to point the nose on this heading, and we're going to travel this many miles this direction, and after 6 minutes, I should be hitting this waypoint. And in another 6 minutes, I should be hitting this waypoint, and so on and so forth. And once we've sort of got those checkpoints nailed, we may have to make some corrections. So we correct the way our airplane is headed so that when we finally we continue on, we can have some certainty that we're going to get to the right place at the end. So that's the method. So these different legs are really going to be checkpoint to checkpoint to checkpoint. Okay? So, well, let's start. Let's actually not go to this just yet. We're going to start with NM83, and then we're going to end at KLLN. But let's go to ForeFlight and just put this in. So a couple of different methods for doing this. It doesn't even say NM83 until you pull it up. So this is Hobbs Industrial Air Park. That's NM83. I'm gonna go here. Well, I didn't do that right. I want to add that to the route. Oh, yeah, I did too. So that added it to the route. Okay, let's add KLLN. Okay, now we got that route. So there, yep, that's exactly what I'm looking to do there. So from here to there, that is, it says here on the flight plan, a 63 nautical mile flight. Okay, the other way to see that is just to touch the leg, and we can see that it's 63 nautical miles at 35 degrees magnetic. Okay, now that's something we can actually go ahead and write down. For each leg, we have from somewhere to somewhere, and the distance, and the magnetic course. Okay, magnetic course. Now that's what's given here, the magnetic course. And you know that because it says course, 35 degrees magnetic. It's M for magnetic. So since we're going to fly a straight line and just use checkpoints, the magnetic course is going to be the same for every leg. So it's 35 degrees. All right, and we'll come back to this in a minute. All right, that is our route. So now that we have this route, we need to think about checkpoints. Checkpoints need to be visual references that you can find, that you can easily identify. You don't want to just say, oh, there's a little intersection in a road here. Well, are you going to be able to decipher that intersection as opposed to some other one? It needs to be well-known, easy to find locations. And another point of advice here, and this is a trade-off. So when you use checkpoints that are directly on your line of travel, that's great because you can fly right over the top of them. If you're a little off, you can get right over the top of them, and that gets you right back on course. The bad thing is you can't see anything that's right on top, right beneath you. When you fly right over it, you can't see it. So it's a little bit of a trade-off here. Now, when you're a little off course, or you can weave around and then find it and then fly right over the top of it, that helps you get right on course. But most of the time, I think it's better actually if you can find stuff beside you. So as we go along here, we're going to use ForeFlight's features here to get a distance. So I use my two fingers. If you're not familiar with this, two fingers on ForeFlight, and what it puts a scale up here, and I see that from the distance from my starting point, NM83, to this abandoned airfield, which is recognizable, 12.5 nautical miles. Okay, that's really helpful. So 12 miles out from my starting point, there's this old airport, a closed airport, but it's easy to spot. So this is something I know about, easy to find. So I'm just gonna put my finger here. I'm gonna create a new, what that's doing is putting another waypoint in my flight plan. And so that's where I want it. I hit the coordinates that gave me. And so now I have a leg here that at this location, I want to be able to look to the left and see this field. Now you think, well, how close is that? Well, let's use our fingers again. It's about 4 miles. So about 4 nautical miles out your left window, you'll see that abandoned airfield. That's a good distance. That's easy to see. And you know, if you've been flying very much at all, it's fairly easy to gauge that kind of distance too. Okay, that's far enough away from your airplane, you'll see it. It's not going to be buried underneath your belly, but it's not so far away that you're having trouble finding it. All right, how about we just keep on running up the course here and find some other stuff? Well, we have Denver City Airport right here. So that means that we have not only an airport, but a city to identify. Sometimes airports are hard to find, but a city is pretty easy to find depending on the terrain. Out here in West Texas is where this is at. It's really easy to see a city. There's trees and houses and stuff. So we just come over here and do the same thing again. Try to keep my line straight. Put another waypoint. So now we have a second leg. When we get to that second leg, out the right window should be Denver City Airport, or Denver City, the city. So that'll be 5 nautical miles off course, off to the right. Okay, following the same method here. Here we're gonna also pass Plains, the city of Plains and its airport off to the north. Once again, off to the left. So actually, I think the city is easier to identify than the airport in this case. So I'm going to put the mark right next to the city, not so much to the airport, even though that's not much distance. And after that, our next leg, which we can find out the length of by just touching it, our next leg is 31 nautical miles. And I'm going to say that doesn't even, not only is there not any good waypoints on the way that are easy to spot, maybe there's one here, another town, but it's so close that you'll already see your destination. So by now, by this point, the pilot should have been able to calibrate anything, any kind of corrections needed should be done by this point. And now you can just fly the heading indicator on your corrected heading, if you had to correct it, all the way to level land. All right, so let's start defining each leg here. So we're starting at NM83, and our first checkpoint is this abandoned airfield on our left. So I'm just going to call that, for the purpose of this, I'm just going to call it like the abandoned airfield. Okay, and I'm going to make a note over to the right side. I'm just going to come over here and say on left. Maybe just write a little 5 miles. 5 miles to the left. You know, just something that I can remember. Remember, when you're actually flying it, you're going to forget a lot of this stuff. So, all right. So then that's going to be the first point of the next leg. Abandoned airfield to where? Where's the next one? The next one is Denver City. So I'm just going to say DC for Denver City, and then DC is going to be the beginning of the next leg, and the next leg is then Plains. Okay, now for the second leg, abandoned to Denver City. So when we get to Denver City, where's it going to be? It's going to be right 4 miles. Okay, Plains is going to be left even less, about 4 miles. Okay, Plains is going to be left 4 miles. You sure want to get this stuff right, because otherwise you may be looking in the wrong spot for your waypoints. All right. So then finally, the last leg is Plains to KLLN, which is our landing point. All right, now we need to fill out distance information. So this is really easy with ForeFlight. You don't have to use a plotter to measure all this stuff. ForeFlight's got it built in. So just touch the leg, 12 nautical miles. Okay, next leg, 9 nautical miles. So 12, 9. See how easy this is to fill in? 11. And the last leg, the longest one, is 31. 31 nautical miles. Now, this is a straight line, or it's straight enough. The magnetic course is going to be 35, 35, 35. So that's the same for all of them. That also means the true course is going to be the same for all of them. So once we calculate the true course once, it's the same for all legs. The altitude I've selected to fly this is 6,500 feet. And I'm just going to do that to make it easier. Okay, 6,500 feet. And before you say, wait a minute, 6,500 is for going west. And you're supposed to be odd plus 500 going east. Well, that's above 3,000 feet. We're right on the edge of 3,000 feet AGL here. So I'm just selecting 6,500 just because. All right. So true course. True course. Now up here, if you can see it, and this is, if you can't see it, this is probably on your own E6B as well. True course minus, true course is, it's actually the reverse. Your E6B will have magnetic course is true course minus easterly or add or plus westerly variation. So what does that mean? Remember, whenever you are using sectional charts, when you use a plotter on here and you start drawing lines and measuring angles, you're measuring against these lines here, these north and south grid lines. Those are true north and true south grid lines. Well, ForeFlight does us a little bit of a favor here, sort of. We still have to calculate it, but ForeFlight tells us something. Remember, it shows us that leg is 36 degrees magnetic, not true. Okay, that's a magnetic course. So that means we have to back calculate the true course, because when we do wind calculations, we're always dealing in true references to true north, not magnetic. Okay, so you might remember the true course calculation. To go from true to magnetic is the one that we memorize. East is least, west is best. So you subtract easterly variation and you add westerly variation. But that's to go from true to magnetic. This time we're going magnetic to true. So it's magnetic course plus east minus west variation. So we know our magnetic course. We need to know our variation. What is it? Well, we're back to the sectional again. All right, here's our course. And on the sectional, there's that magenta dotted line, or dashed line rather. That's the isogonic line, if you remember what it's called. We're going to follow it down. There it is. 6 degrees and 30 seconds east. So that's 6.5 degrees running through part of our course here. And over to the right, the next one is 6 degrees. So we have 6 degrees, 6.5 degrees. Okay, I'm going to say for this course, close enough, we're going to call the variation 6.5 degrees east. All right, so I'm just going to make a note of that here. Variation is 6.5 degrees east. All right, now it's time to calculate our true course. Our magnetic course was 35 degrees. True course equals magnetic course, because we're going backwards, plus easterly or minus westerly variation. So that means true course equals 35 plus easterly variation plus 6.5 equals, what is that? 41.5 degrees. Okay, so 41.5 is our true course. 41.5. It's the same for all of them because it's the same course. Okay, how about wind speed? We have to find what our wind speed is. And you know what? Before we even go on further there, let me do a couple of things. This is going to be, we're going to be flying, down here, we're going to be flying a Cessna 150 B model. Tail number doesn't matter. We're about to find this air temperature aloft. What about the true airspeed of this airplane? Well, this depends on how fast you want to run it, how hard you want to run the engine. So we just pick, you have to kind of decide this before you start doing all the rest of this stuff. So let's just say we decide we look at the performance data in the POH and decide we're going to get a 100 knot. Yeah, we're going to do a 100 knot cruise speed, and it's supposed to be burning 5 gallons per hour. 5 gallons per hour, 100 knots. This is true airspeed, not indicated. True airspeed. And that's, of course, at the altitude we're going to be flying at, 6,500. This is based. This all varies with density, altitude, and all that kind of stuff. So, some of what we're about to find is going to determine then what that performance is going to look like. But for this purposes, I'm just showing you how to go through the process and what elements need to be in place. So I've already gone to the POH and determined it's going to be 100 knots true at 5 gallons an hour. All right, so what's our air temperature aloft and our wind speed? Well, that sounds familiar, doesn't it? We go to the winds and temperature aloft chart. So there's a couple of ways to do this. I'm going to start at the first airport and then just touch on the airport, and I get all this optional information. I'm going to go to weather and then winds, and that gives us, based on times, so at 1:30 p.m. it gives me all these altitudes. It gives me winds and temperature aloft. Okay, and then so I have a 1:30 p.m. today, a 4:30 p.m., a 6:30 p.m. Let's just use 6:30 just because. Okay, so 6:30 p.m. We're gonna say 6,000. Our cruise altitude is 6,500. That's awfully close to this. So I'm just gonna use what it's got here. So I'm just gonna write this down real quick. So at NM 83, we got 6,000 feet. All right, what do we have? We got 59 degrees Fahrenheit. That's pretty warm. 59 degrees Fahrenheit. The wind is 275 degrees at 27 knots. It's a pretty good wind. Okay, that's at that initial airport. That's point number 1. Okay, at 6:30 p.m. Let's make a note of that. Okay, obviously you want to get a time around the time that you're closer to the time you're flying. And if your time is in between these and your altitude is in between, you do interpolation, which is a real pain. It involves a lot more calculations. But, and ForeFlight will do some of this for you, actually. But we're doing it sort of longhand here and making some assumptions along the way, showing you where to get the data and what to do with it. So, now that we have that, let's go to the end of the route and see how different it is. Okay, there's well, I got the runway. So there's level land, weather, winds, and we're going to go to 6:30 p.m. and I still got it in Mountain Standard Time, even though it switched time zones. Okay, 6,000 feet. We got 57 degrees. KLLN. Actually, that's 0.4. So KLLN, 6,000 feet. That's 57 degrees Fahrenheit. The wind is forecasted to be 238 degrees at 26 knots. 238 degrees at 26 knots. All right. So let's take a look at this. The temperature is about the same. The wind direction is 30 degrees difference. Yeah, 37 degrees difference. So that may be a factor. So let's now then go to the middle and go. Plains is right in the middle. So let's look at Plains Airport. Okay, Yoakum County. We want to see the details of it. I want to go to the weather and the winds. So Plains is going to be point number 3. what is this? F98. We want to go to the same time, 6:30 p.m. So that's the same. 59 degrees Fahrenheit, 275 at 27 knots. All right. So in the middle, we have 275-degree winds, middle and end. So it's only over here at the beginning we have this 238. So if we're gonna just pick one for the whole trip, if we do that, we definitely want it to be closer to the 275, and our wind speed is about the same. And just for fun, since we're doing this, we can come back here and get a little closer and say, what about Denver City? What are they saying? Denver City details, weather, winds. Look at the same time. 275 at 27 knots. So far, it looks like about 3/4 of the flight is going to be 275, sorry, at 27 knots. So I'm saying that's actually what we're going to go with. That's where we're spending the majority of our time. We're going to go with that. So, all right, wind speed. What's it going to be? 27 knots. Wind direction, 275 degrees. Now remember, this is true, and it's noted up here. This is a true direction. So something else here. As we look at winds and temperatures aloft, winds. So this winds and temperatures aloft. These are printed. These are written, and the memory aid is, if it is written, it is true. Kind of like what we say some similar things. You know, if somebody just told you, well, it may not be true, but if it's written down, it's true. You know, it doesn't hold water very good, but that's the memory aid. If it's written, it's true. So weather reports that are written, like METARs, like the METAR, the TAF, those that are written are true north references. The degrees are a reference to true north. If you hear it, it's not. Okay? If it's written, it's true. If you hear it, it's not. So if you hear it, it's like if you hear it on the AWOS or the ATIS, it's referencing magnetic. It's a magnetic north, not true north. Okay? So we got wind speed, wind direction, and then ground speed. Well, how do we calculate ground speed? Now we're going back to the E6B again. All right, so on your E6B, you got two sides. We have the rate or the speed side, and we have the wind side. On the wind side, you always start with the wind. And if you're confused, the E6B has almost all of them have some instructions on them. So the wind side, you start with the wind. You start with, it says set wind direction to true index. So here's your true index on top. So you want to set the wind direction. We got it, 275. Okay, and I'm going to use this throughout here. Wind direction, 275. So we'll spin this around till we get 275. 270 is west, 275. All right, so there's 275. All right, now we want to move the little hole in the center. All these have a little hole. Some of them have a grommet if they're paper. Move that to some reference that's easy to count from. 100 is the standard. So go down to 100. We're set here. Wind speed is 27 knots. So we want to count 27 up. So it's a positive 27. So that would be 127. So 120, so 25, 6, 7. And we make a little dot. You can do this with pencil or pen. I like to do it in pen and then I just rub it off later. So 27 knots at 275. Okay? All right. So that was step 2. Mark wind velocity up from center point. Step 3 is set true course under true index. Remember, we calculated that a minute ago. Our true course is 41.5 degrees. So now, without touching your mark, let's rotate to your true course, 41.5. 41, and you can see that half doesn't make much difference. It's pretty small. So 41.5. All right, we got it there. Now, step 4, slide wind velocity mark to true airspeed. All right, what was our true airspeed? Remember, this is the airspeed of the airplane. True airspeed is 100 knots. So we're going to take that little mark we made without rotating, take the mark you made, and we're going to slide it up to whatever our true airspeed is. That's going to be 100 knots. It's only a coincidence that it's the same 100 we were using as a reference a minute ago. So we slide this until we get to put that mark on 100 knots. Okay? Now, under the hole or the grommet is shown your ground speed. So that's 100 and, well, it's about 105. It's between 104 and 105. No, actually, sorry, 115. 114, 115. I'm going to call it 115. So ground speed, 115 knots. All right. So what about the magnetic heading? Well, let's make sure we understand what this is about to start with. So if you can see this, we have a course. We're going to be going at 40, we're going to be traveling this direction, 41 degrees. And you know, if we just face this north, we're going to be traveling this direction. And the wind is blowing from that direction. So it's blowing this way. So that means our course is like this. The wind is like this. That means for us to fly that course, we're going to have to turn the nose of the airplane and fly sort of into the wind, crabbed, right? So we're going to have a wind correction angle of something to the left. Well, our magnetic heading is, and that's also on the E6B here, magnetic heading, sorry, it's this one. Magnetic heading equals magnetic course minus left or plus right wind correction angle. So on our E6B, we have this wind correction angle. So we have our dot. We come over, and you can see it's got 10 degrees, 20 degrees. So we come over 10, and this is 2, 4, 6, 8, 10. These are by twos. So 10, about 11.5 degrees. Yeah, about 11.5 is what this is showing. Yeah, we call it 11 or whatever. We'll do 11.5, and it's a left correction. So our magnetic heading, which is what we're after, equals our magnetic course minus left or plus right wind correction angle. So magnetic heading equals, what's our magnetic course? 35 minus, let's make that 5 legible, 35 minus our left 11.5 wind correction angle, 11.5 degrees. 35 minus 11 is 24, minus that half, 23.5. That's 23.5 degrees. That's your magnetic heading. So we put 23.5 degrees. Okay, and that'll be the same for all these if we're using it, and I'm calculating all these as the same. And sometimes on a longer trip, of course, they won't be the same. And they may not be going the same direction either. So that's how you use the wind side. And then I just rub that pen mark off. That's how you use the wind side of the E6B. So what does that mean? Let's take a look at this again. We're saying we have a course of 35 degrees. There's your 35 degree course. And we're saying we have wind out of 275, right? 275 blowing like this. So that's going to push us along that course, but it's also going to push us off to the right. So once we calculate the strength, our magnetic heading turns out to be, we don't need to be pointing our nose at 35 degrees. We need to be pointing our nose at 23.5 degrees, going the speed we're going, and we should be flying straight down that course without being blown off one way or the other. Okay? And this is literally this is magnetic heading. Okay? Magnetic heading is you set when you're on the ground running and you got your DG, or your heading indicator, as it's called, spooled up. You make sure you set that with a compass, or even better, set it to the runway before you take off. If you're taking off of runway 12, you set your heading indicator to 120 degrees, so you're lined up with the runway. So when you take off, remember it's a gyro instrument, so it's stabilized. So when you take off, you should be able to set that thing at 20. You should be able to point the airplane at 23.5 degrees, and then you will be flying that course just like this, if the winds turn out to be what you expected and all that kind of stuff. Okay? Now, next question is, how much time is it going to take? So how much time, because what we want to do, here's the method. We're going to start here, and we're going to fly so many minutes, and then we're going to be looking. When we're so many minutes out, we should expect to see this airport, this old abandoned airport on our left. And then so many minutes later, we should be able to see this on our right, and so many minutes later, this on our left, and then so many minutes later, we should arrive at our destination. But we're checking ourselves along the way. This is called dead reckoning. When you get to the point you're expecting to be at, you have to reconcile everything with it. So if you went off to the right and you see I'm further than I expected to be, then you need to make a left correction. And then let's say you still are off to the right, you're closer to this than you expected. Well, then you may make a further left correction. Or if you're off to the left, a right correction. You get the idea. By your checkpoints, you start correcting the course you're flying and see if you can make it better. Because, the real world is not the same as you planned. And also, you may get distracted and you're flying. You may not be able to hold that line the way you hoped you would. So, that's what we're going to do. So we need to know how many minutes of flying past Hobbs Industrial is it going to be before I should expect to be at my checkpoint. All right, well, this is pretty easy to do. If you pull up a calculator, we know we have, let's just clear that all out. We know we have a distance of 12 nautical miles we're covering, and we're going at a speed. This is your ground speed. Remember, this is ground point to ground point, so it's your ground speed that matters, of 115 nautical miles, 115 knots. So you just divide 12 by 115, so 12 divided by 115 is 0.10. That's 0.10 hours. If you want that in minutes, and we definitely want it in minutes, we multiply by 60, because there's 60 minutes in an hour. That's 6.3 minutes. So I'm just going to write that down, 6.3 minutes. The next leg is 9 nautical miles. You're going the same speed. So 9 divided by 115. Now that's in hours times 60 to put it in minutes. That's 4.7 minutes. 4.7 minutes. Okay. What if we use the E6B for this? How would you do it? Well, this is the speed side. Remember, you got the wind side and the speed side. So how this works, you stick the little arrow. Some of these are notated differently, but the arrow that says rate, you put the rate, and it has a guide as well here for you. So it says you put the pointer at miles per hour, and in this case in knots, but it doesn't matter, miles per hour or knots. So you set the pointer at your speed on the outer side. So now this is 80, 90, and it goes 10, 11. 80, 90, 100, 110, 120. The E6B is funny about that. Like, you just have to get used to it. There is no 100 out here for you to point at. That 10 is the 100. So in this case, our speed, we're talking about true airspeed. Oh, no, we're not, are we? We're talking about ground speed. Ground speed, 115 knots. So there's 100, 110, 115. So it's at the 11.5 mark. So you set your triangle, your speed rate. You set the rate at 115 on the outer, okay? And yes, set your speed at 115 on the outer. And then you go to the outer ring, the outer scale here, and you find your distance. And on the inner, we'll read the time. So our rate is now fixed at 115 knots. So now we say we're trying to see how long it takes to go 12 miles. So we're gonna, now there's a 12 right there, but this is 100. That's 120. Remember, we're scaling down by a tenth. So we're gonna come down here and go 70, 60, 50. We're looking for 12. We got to go way back here. Way back here. Well, gosh, if we went to 30, let me just show you this. If we're going 12 miles, let's say we're going 115 miles to help orient this. If you're going 115 knots in speed and you go 115 miles, well, 115 knots means 115 nautical miles per hour. So 115 nautical miles would be 60 minutes. Okay, well, what's half of that? Half of 115 would be, what, 57 and a half. So you roll down here to 57 and a half, and sure enough, you see 30 minutes on the inside. It'd take you 30 minutes to go half that distance. Well, we're going all the way down to 12. So we just keep moving the scale back. Oh, 12's coming up. Look at that. We've almost gone a full circle. 12. So what's on the inside now? We got 70, 80. This is 60, 70, 80. So down at this scale, think about how we just scaled it down. 30 minutes. That was 10 minutes, 9, 8, 7 minutes. So for 12 nautical miles, we're looking at about 6.3 minutes. So about 6.3 minutes. Hey, that's exactly what we saw here. So 11 nautical miles, your speed, your rate is fixed. 11 nautical miles, what's that going to be? Like 5.5 minutes. Nope, that's not right. It's less than that. Well, we already calculated that one. Oh, that's 9. So yeah, that's about right. So 5.5 minutes. 5.5. Now let's check it with a calculator. So that's 11 divided by 115. 11 divided by 115 times 60 for minutes, 5.7. So 5.7, that's close enough. I'm going to leave it for now. That's actually just 12 seconds of difference. So how about the long one? Now this one's maybe more important. 31 miles. Okay, I think we just did that, didn't we? So we got our rate, our little pointer is set at 115 knots because that's our ground speed. 115, and we want to know what it takes to go 31 miles. So we turn it until we get to 31. 31 is right there, and that is 16.2468. Yep, 16.2 minutes. 16.2. Now let's check our math just to make sure. So 31 divided by 115 times 60. Look at that, 16.2. So the E6B is a calculator for you if you just know how to use it. All right. So now we have our times here. Now we can also calculate fuel burn. Okay, we said, we already looked it up in the manual, we're burning 5 gallons per hour, or at least we're planning for that. Maybe it's less, but we're gonna be conservative and plan 5 gallons an hour. So 5 gallons per hour, how many gallons per 6.3 minutes? Well, with a calculator, this is pretty easy as well. So 6.3 minutes divided by 60 minutes, that's 0.105 hours times 5 gallons an hour. That's half a gallon. That's 0.52 gallons. Okay. By the way, you can also do that with this, but I'm not going to bother with that now. You can do it the same way. The rates work the exact same way. So that's about 0.5. I'll clean it up. 0.5 gallons. Okay. How about this one? So I'm pointing to the wrong thing. So 4.7 divided by 60. That's telling you so 4.7 minutes divided by 60 minutes is 0.078 hours times 5 gallons an hour. That's 0.4 gallons. So then 5.5 minutes, you can see it's about the same. You can start to see a pattern here. You could easily just say, oh, that's going to be about a half a gallon. How about 16 minutes? 16 divided by 60 times 5, 1.3 gallons. So 1.3 plus 0.5 plus 0.4 plus 0.5, we can expect to burn a total of 2.7 gallons in flight. Now that's not considering the burn of flying patterns and taxiing and run up and all that stuff. 2.7 gallons in flight. Now you may think that there's no way that's right. But sure, look at our times. We're talking about 16 minutes plus 5.5 minutes. So what do we got here? 10, 15. We got a little over half an hour flight time at these rates with that kind of tailwind. A little over half an hour flight time. We're burning 5 gallons an hour, so a little over half of 5 gallons is 2.7 gallons. So yeah, it does make sense. Okay? All right, now, how are we going to execute this? So some of you are going to already realize that there's a problem here. Oh yeah, I never got the temp aloft written down here, but that doesn't matter. But to fill it in, we were using 59 degrees Fahrenheit. And that temperature aloft affects your performance. So at 6,500 feet with that kind of temperature, can we really get the engine to perform well enough to get that airplane to move at 100 knots true? I don't know. But today we said, yes, it can. So that's what we did for planning. Now the last one is this actual column. So we take off, all right? Right when you take off, you note the time, or even better yet, you start a timer when you take off. But you could also just note the time. You could say, 6 o'clock, I took off. And started flying. You take off and you start flying on your heading. What heading? 23.5. That is the heading we are going to fly with our heading indicator. Set with the compass, verified on the runway. If the runway is a little different, then we set it to the runway heading and we take off. Of course, there's compass correction and all that kind of stuff. So we're flying 23.5 degrees. But you notice, you might think, well, wait a minute, we're going to fly off this runway and then we're going to be way over here and we're going to be climbing. We're not going 115 knots yet. We're climbing and aren't we going to miss it? Yes, you are. So this might not have been a good choice. I have this all coming directly from the airport. So realistically, if you were going to do something like this, you would actually want to climb. You'd want to know how long you're going to climb and how many miles that takes. And you can calculate all that. And then you want to, if it takes you 5 miles to climb up to this altitude that you're going to cruise at, then you might start looking for a waypoint 5 miles away from the airport presumably in the direction you're flying. And you say, all right, I want to start my times here at that waypoint. Understand that? So maybe if I can find this field, that abandoned airfield, it may be that I should have flown out here and gone straight to that abandoned airfield, and that's my first checkpoint. Really, I could ignore this first part, and I start my checking right there. I start my time, and then I go from point to point to point. So maybe something like that. Here's another way to do it. If this is exactly what you want to do, because maybe you're going to get lost. Maybe you're not familiar with this area. So maybe what you can do instead is you take off from the airport and you can climb over the airport. That's another method. In fact, this is a method that you use in mountainous airports sometimes when you can't just take off and climb and go over a mountain. You have to climb above the airport. So we could climb up and up and up and up. It takes more time. It burns more fuel. We climb over the airport. And then once we're up to our cruising altitude, we just swing around here and we still have the airport in sight, and we can go over the center of the airport and get set up for cruise already. And then we get on that heading. We get on our 23.5 degree heading at our cruise altitude, at our cruise speed, and that's when you start your time. So you would write it down. You'd either start the timer or you write down the time. It's easier actually to look at your watch or your iPad or whatever and write, it's 6 o'clock right now. Then you know when to expect your first waypoint. You're flying your heading, you're maintaining altitude, and you know that it's going to take you 6.3 minutes. So at 6:06 or so, you should be seeing this abandoned airfield on your left, right? About 4 miles out your left window. So you stay on heading, you maintain heading so that you're flying here correctly. Now, if your heading indicator is off, then you're going to be off. This is why we're going to do dead reckoning. So at about 6 minutes, maybe 5.5 minutes, you ought to be looking really close. You ought to be looking the whole time, really. But expecting at 6 minutes or so, 6.3 minutes, I keep circling this, at about 6.3 minutes, so about 6:06, you ought to be seeing this straight out your left window. Maybe not straight out, right? Because your flight path is actually like this. Your airplane is doing this, so you need to think about that too. The heavier the winds, the more you can't just look out your window. You have to think about what your path of travel is and kind of look out, the left side of the path of travel. And so let's just say you get there, it's 6:06 and it's pretty much perpendicular to you. And it looks to be about 5 miles to your left. So you say, yes, I'm on track. So you write down 6:06. Perfect. Everything's going great. And you keep on going. You stay on your heading of 23.5. Okay? You stay on your heading. You're going to be on that heading for another 4.7 minutes before you should see Denver City out your right window. Well, let's say by the time you get there, you do see their time is good. So 4.5 minutes later, so now it's like 6:11. So at 6:11, you see Denver City out your right window, but you notice that it looks to be like 6 or 7 miles off. It looks further than you expected. You expect it to be 4 miles out your window. So that would tell you that you must have drifted a little bit to the left. So what do? You make a correction. You're having a guess, use some good judgment here. You were flying 23.5 degrees and you say, well, I was on my heading. So it wasn't me. I think I need to adjust it. Maybe the wind is a little different. So maybe you go 2 or 3 degrees to the right. So maybe now you start flying maybe 26 degrees. So you make an adjustment, fly 26 degrees, and you do that for another, 5.5 minutes until you see planes out your left side. And of course, you make the same adjustments for time too. If you end up getting there early, then you can make an adjustment. You can use a calculator and scale it down. Or late, same thing. So the alignment is what's most important here, as long as you're close on the times. So let's say this time you hit planes Planes is out your left window, and it looks like it's about the distance that you said, which is out the left by 4 miles. Well, that all looks great. So you're going to stick with 26 degrees. And that means your last leg, which is your long one, remember, it's 31 miles, and it's going to be 16 minutes holding a 26-degree heading. And in 16 minutes, you should be right over top of the airport and level land. Now, like I said earlier, if you're right over top of the airport, you're not going to see it. So you can expect, oh, look, we have another marker here. We're going to have sundown coming up right over the top of this little town of Sundown. Well, when is that going to be? Well, I don't know. It's going to be before it. Actually, we could have put that in as another waypoint. 8 miles back. 8 miles turns out to be what, about 5 minutes. So take 5 minutes away from this. At about 11 minutes, you should be over sundown. That gives you another waypoint. Oh, there's another abandoned airport out here to the right. We could use those as gauges as well. And you can do whatever you need to do here with things that you can identify. And by the time you get close then, if let's say you don't see any of those things, all you did is just fly this last 16 minutes. At about 15, 16 minutes, if you don't see the airport, you want to then carefully just start circling. Because if you're here, maybe you're out here actually, and you start circling and you're looking below you and looking around you to see where am I? Where's that? Oh, there's the airport. So I drifted off course here. Or you're circling out here and find it there. Or you're right on top of it, and as you circle, you can see it below you. So making those corrections, getting those waypoints set, that is what is called dead reckoning, and this is how you do it. And that's how you use the E6B to help you out.